Hello everybody and welcome to my talk, Integrating SUSE Manager with Ansible. My name is Christian and I'm working as a consultant and as a trainer at SVA, one of the biggest German IT system integrators. And today we want to talk about SUSE Manager or OUNI and Ansible. So let's have a look at the agenda. So first we will start with a recap. SUSE Manager automation possibilities, or in other words, what is offered out of the box today. After that, we will have a look at how to automate SUSE Manager installations. And after that, I will show you the OUNI Ansible collection, a project I've been working on the last couple of months. And in the end of the slot, I will have some screenshots of a demonstration about how to integrate SUSE Manager with Ansible into AWX in order to have a fully automated Ansible-based patch management workflow. So let's start with a recap. SUSE Manager automation capabilities. What do we have today? So first of all, we have the XML RPC API, the good old default API. That's pretty old. It has been introduced back then in 2008 in Spacewalk. These days, it's kind of hard to use as it requires special client libraries that aren't that modern anymore. And as a result, we now also have the HTTP API. That's a new JSON over HTTP API that's way easier to consume than the XML RPC API. It has been introduced in OUNI 2022.05 and it's supported in SUSE Manager 4.3 and 4.4. So it's quite new. Besides that, we also have the Space CMD, the command line interface to the API. That's also quite old, but not bad. It's a really good tool. It offers many commands, so you can basically do the most things you can do in the user interface also from a command line. And it also offers a shell mode. So if you have plenty of tasks you're doing quite often, you can simply start SpaceMD like a shell and run your commands in order to patch systems and so on. Beside that, we also have SaltStack. That's one of your USPs of SUSE Manager. It's a mighty infrastructure as code solution, and it can be used for comprehensive configuration management. Don't get me wrong, SaltStack is a pretty good tool, and a lot of customers like and love it. But other customers also like and love Ansible, and they already made the decision to go for Ansible in their automation workflow. So I thought there must be a possibility to combine those two worlds. But maybe let's kick it off with a short code demonstration and talk about automating SUSE Manager installations in under 10 minutes. So I'm a consultant. I do a lot of SUSE Manager and OUNI installations. I do them really, really often. And I want to ensure that it's reproducible what I'm doing. So I have a generic workflow, how I do installations for my customers. And I created an Ansible role 2 years ago in order to automate the initial SUSE Manager or OUNI installation, because it's every time the same. You install the same packages, you alter the same configuration files. So I thought it would be great to have it automated. And what you can see here on that slide is this is a very basic Ansible playbook that installs SUSE Manager on a particular host. So we have the playbook name, and we have assigned a host. And because we need root permissions, we also set become to true. And below that, you see that we have one particular role assigned to this playbook. And the role has the name stdevil.ouni, which is the name of the Ansible collection I will show you in a minute. And Sura is the name of the Ansible role. And this Ansible role has two variables assigned. One is the registration code, and the other one is the email address you see in your SUSE Customer Center. So when you buy SUSE Manager, you will need to create a SUSE Customer Center account, and after the purchase in your account, you will see the registration code that can be used in order to install your product. So these are the information that are entered here, and this is sufficient in order to install SUSE Manager server. So you can simply run that playbook, go grab a coffee, and in something around 6 or 7 minutes, depending on your internet connectivity, the installation is finished. Of course, this also applies to OUNI. So don't get me wrong, even though the Ansible collection has the name OUNI, it applies to both OUNI and SUSE Manager. So let's see another example, which is this playbook. And this playbook installs a Uni server and also some third-party software repositories. But let's start with the role. We see that we have the same role name, stdevil or Uni server, but now we do not have any SUSE customer center information like email address or registration codes, but we have mentioned a particular Uni release. So in case you don't want to go for latest and greatest, you can pin the installation to a specific version. In this case, the version is 2023.06. And after the installation of Uni server, we also want to ensure having software channels for the clients we're going to bootstrap and to manage. In this case, we want to have the repository for OpenSUSE Leap 15.4 for the x86 architecture. This is what you can see here in the Uni channels variable. So what the role does is after the installation, it executes the Spacewalk Common Channels utility that always has been part of Spacewalk in the last 10 years or so. And it's a configuration file where you have the most recent and commonly used Linux distribution software repositories like OpenSUSE, like Debian, Ubuntu, Alma Linux, and so on. And just by mentioning the particular name of the configuration file, the channels are automatically created after the installation. So after you came back from your coffee break, you not only have the Uni server installed, but you also have the software repository stage and download is already taking place. What we also can see here in this example is that this playbook also enables monitoring support. And those are the two lines. In the end. So Uni enable monitoring makes sure that all the software components on the Uni server that are required for gathering monitoring information are enabled. So there are exporters for the database, for the Java processes, and so on. And we also install the SaltStack formulas that are required in order to have a managed system becoming the Grafana or Prometheus server. So you're good to go after running this playbook and just need to pin the monitoring formulas on a managed system, and you have a fully working monitoring stack. And this just with a couple of lines of Ansible code. Okay, so now we installed SUSE Manager or Uni server. We already staged some content for the systems we want to bootstrap. So the last thing would be also automating the client registration. For this, we have another role, which is the stdevil Uni client role. And as the name suggests, it automates running the Bootstrap script on clients. So by default, you create Bootstrap scripts for all your systems you want to register with your SUSE Manager or Uni server. It's common best practice. So if you have a look at the SUSE Manager documentation, there's a section that exactly describes how this is done. So there's a command that creates a Bootstrap script. And this Bootstrap script simply installs the Salt minion on a managed new system, enables Bootstrap software repositories in order to get the Salt minion installed, and uses an activation key in order to register your new system against SUSE Manager or Uni. By default, this script is named bootstrap.sh, but it's common best practice to have multiple Bootstrap scripts for all the distributions you want to manage. And by default, this role searches for a file that begins with bootstrap hyphen and then follows the distribution name and the distribution version. So for example, if you want to bootstrap an Alma Linux 9 client, this role searches for the bootstrap hyphen alma linux 9.sh file on your Uni or SUSE Manager server. So it's stored below /srv/htdocs/pub. You can look this up in the SUSE Manager documentation. Of course, you can also alter the script name. So if you don't want to follow the naming procedure that is part of the slide, you can simply set a different script file name. That's also possible. So maybe let's have a look at the Uni Ansible collection. We already saw some 3 examples about installing the server and also bootstrapping clients, but there's even more in this collection. First of all, I have to point out this is a work in progress project. So I started it a couple of months ago. The first roles I have been using for 2 years, and I decided to make a Ansible collection out of it so that other users can can use it and give feedback. So it's available on GitHub and also on Ansible Galaxy. You see the URLs here on that slide. So if you have any problems or feature requests, feedback is always welcome. Just create an issue or drop me a mail, and we love to hear your feedback on this. And if there are any bugs you see, you can simply create a bug report, and we are happy to help. Currently, this collection consists of 3 various roles. The first would be the storage role, which is the server preparation. So in order, before you install SUSE Manager or Uyuni on your system, you want to ensure having a dedicated partition for the database or for the software packages you're going to download, for the cache, and so on. You might know this from the SUSE Manager or Uyuni installation documentation. So we simply grab the best practices and put it in Ansible code. So you just need to assign a dedicated hard disk, for example, and the role will automatically partition the hard drive and set up an LVM setup, and also will create the file systems for you and the mount points. So you don't need to do this manually. The next role is the server role, which actually installs SUSE Manager or Uyuni. We already saw this a couple of slides ago. And we also have the client role that does the client bootstrapping. Besides this, we also have various plugins. For example, we have modules for managing patches, software package upgrades, and running OpenSCAP scans from within Ansible. So in your Ansible playbook, you can simply write a task which executes this module in order to install patches on a managed system using Ansible and the API. So you don't need to use Space CMD or SaltStack or the web interface in order to automate your patch installation. And of course, we also have a dynamic inventory, but we will have a look at this later. Maybe let's start with the easiest task, installing patches. In order to install patches using Ansible, all you need is this collection and of course the install patches module, which you can see here on the left on this slide. So the first 3 parameters are connection details. So we have to specify the Uyuni host, which can be IP address or host name. And of course, we also need to supply username and password of the user we want to leverage in order to trigger the patch installation. So in this case, it's an admin user, but it can also be a dedicated user that only has limited access to a subset of hosts, for example. The name parameter specifies the host that needs to be patched. In this case, we have one single server mentioned here. It's myserver.localdomain.log. But of course, you can also use this with the dynamic inventory and using the task delegation of Ansible. So if you have a host group of hundreds of server, you can simply write a playbook that uses this host group and delegate this task using the delegate_to parameter of Ansible. By default, if you don't specify any further settings, all available patches will be installed, which can take a lot of time. But you can also do include or exclude patterns. And in this example, you can see the last 3 lines of code on the left. This is an exclude definition. So exclude_patches defines a set of patches you do not want to install on that particular system. So for example, if you know there are those 2 patches that simply won't work on that machine, then you can simply exclude them and all other patches will be installed. The other way around, it's also possible. So you can also define include patches, and this will result in that only those patches listed will be installed and no other patches. So it's easy if you stumble upon any patch installation errors to ensure that this won't happen the next time. After installing patches, you might want to run OpenSCAP compliance checks. And for this, we also have a module, which you can see here. It's called OpenSCAP_run. Of course, we also supply the Uyuni or SUSE Manager connection details, hostname, username, and password. And of course, we also mentioned the system we want to check compliance against. And the last 2 parameters in this code example you can see here. The document parameter is the path to the XCCDF catalog document. So in this example, it's an example code or an example catalog that comes with OpenSUSE lib. And by using the arguments parameter, you can also specify additional parameters of the OSCAP command. So for example, if you have an XCCTF catalog that consists of many profiles, you could set here -- profile default to use one particular profile of the OpenSCAP catalog. Let's have a look at the dynamic inventory. This can be very useful, and the first step is to configure the dynamic inventory. So like for any other Ansible dynamic inventory plugin, you would need to have a configuration file. This is what you can see on the left of this slide. This is a YAML document, and it needs to end with .uyuni.yml. So even though you're using SUSE Manager, the postfix always must be .uyuni.yml. It won't work if you don't use that postfix, and it can take a couple of minutes if you're debugging an issue, and then you see it's simply the incorrect postfix that has been assigned. In this configuration file, we are specifying various things. For example, the first line is a plugin name. You can just leave it like that, but afterwards we need to specify the Uyuni or SUSE Manager connection details. So we have a host name, which can be a FQDN host name or the IP address. And of course, we also need to specify the username and the password of the user we want to leverage for communication against the API. You can also skip the SSL verification in case you're using self-signed SSL certificates. And in case you want to only see the IPv6 addresses of your machines, then there's a parameter called IPv6_only that can be set to true. You can also limit the list of systems to a particular host group. So in Uyuni or SUSE Manager, you can create various host groups, and systems can be part of multiple host groups. And let's say you have hundreds of systems in your inventory, but you don't want to have them all in your inventory, but only a subset. You can simply use the groups parameter and list all the group names you want to have in your inventory. This can speed up things heavily. The user interface of Uyuni and SUSE Manager offers the possibility of setting custom information values to systems. It's like key value store, if you want to call it like that. And these information can also be part of your inventory. So let's say you have various information set on the web interface and you want to use those information in your Ansible code. You should set show custom values to true, and you will see it. You will also see it in a minute how this would look like in the output. And the last feature I want to mention here is the pending reboot only variable. That can be also quite useful. It is once enabled, it will only show systems that actually require a reboot because you installed a new systemd package version or you upgraded the Linux kernel without having live patching. You will notice that those systems in the SUSE Manager or Uyuni web interface will have an exclamation mark and an information that those systems need to be rebooted. And what you could do in order to automate mass rebooting all those systems is you could have a second dynamic inventory configuration where you have pending reboot only set to true. And then you can simply execute a playbook that reboots all those hosts that are part of this inventory. Might be an advanced topic, but I think it is quite interesting to know that this feature exists. Let's assume you wrote the correct dynamic inventory configuration for your Uyuni or SUSE Manager landscape. How would it look like using it? One command for testing Ansible inventories is the Ansible-inventory utility, which is executed here on this slide, as you can see on the left. So we run the command followed by the homelab.uyuni.yml-list. So this will simply list all the hosts that are gathered from these dynamic inventory. So once this command is executed, the plugin will create a real-time API communication to Uyuni or SUSE Manager and will query all the systems that are part of your configuration. And what we can see here, that we have a host group that is called test. In this group test, we have one system called Uyuni client OpenSUSE Leap 15. And below that, we have the meta part of the output, which simply defines host variables. And we can see that our unique client OpenSUSE Leap 15 has the Ansible host variable set. So this network information comes from SUSE Manager or Uyuni. And we also have a custom variable set, SUSECon23 system, which has the value of 1. And you can simply use this information and these variables like any other Ansible variable in your code. So you can write a playbook or a role that uses these information in order to do different tasks if you want. So can be quite useful. Have a look at the Uyuni or SUSE Manager documentation regarding custom system information. There's a section that further describes how these information can be set from the web interface. So the next I want to show you is a short demonstration. I'm not a crazy person. We know live demos won't work. So I recorded a demonstration that can also be found in the official GitHub repository. There's a link to a recording, and I created some screenshots, and I will explain what exactly is done in this demonstration. So what you're going to see is an AWX-based patch management workflow. Okay, so in this demonstration, we have an automated patch cycle in one of our labs. And in our labs, we have a hypervisor. In this case, it would be VMware vSphere. So we have several ESXi hosts that are running several VMs. One of them is the Uyuni server, for example, and the Uyuni client. And beside that, we also have a monitoring system. In this case, it is CheckMK. So we use this software in order to keep track of once systems become unresponsive and can't be reached anymore in order to get services up and running again as fast as possible. And our AWX automation workflow uses a variable Ansible collection. So first of all, we have the community.vmware collection that can be used in order to create VM snapshots. We have the tribe29 checkmk Ansible collection that creates downtimes, and we will combine this with the stdevil Uyuni Ansible collection to also have the patch installation fully automated. So what we want to achieve in this workflow is we want to have all that boring patch preparation, the patch installation automated in one step. So independent whether it's one systems or hundreds, we want to have one single button to click, and Ansible does all the rest or all the magic. So it will create downtimes in order to avoid having mails or pager notifications sent to persons that are on call that might be disturbed by this. And also we want to ensure that we have a working VM snapshot. In case that anything goes wrong, we can simply restore the VM snapshot and have the old state back. And yeah, this is what you're going to see. Let's have a look at the workflow template. So this is a screenshot of AWX, where you see that we have various job templates that are executed. The first step would be running the VM snapshot. This is a simple and short Ansible playbook that actually connects to VMware vSphere and creates VM snapshots for all the systems. After that, the next step would be to create downtimes for the monitoring. As mentioned, we do not want to have the person that are on call disturbed. And after the downtime has been created, we're going to install patches that are outstanding on those managed systems. And the last step would be running OpenSCAP security scans to ensure that the systems are still in a secure state. And what you can also see here, the connection between those job templates is a green line. So that means only if creating the snapshot succeeds, the downtime is created, and only if the downtime can be created without any issues, then patches are installed, and only if all patches could be installed without problems, then afterwards the OpenSCAP scan is executed. So in case any of these tasks fail, additional tasks won't be executed. To speed up things a little bit, here's a screenshot of what would happen next. So after we started the workflow, the first step would be that the Ansible playbook triggers the community VMware collection, and this collection creates an API call to one of our vSphere centers. And you can see here that a snapshot has been created. It is called Ansible maintenance, and you can see on the right that it also consists of a short description that tells us it's a snapshot before system maintenance, and it has been created automatically by Ansible. That looks great. So I do not need to do this manually. And the next step is, after we created successfully the VM snapshot and vCenter server, we create and scheduled downtime in our monitoring system. And what you can see here, this is the CheckMK monitoring. And you can see that the automation user created a scheduled fixed downtime for this particular system. In this case, it's just a short downtime, I think something around 2 hours like that, but that's okay for this demonstration. And afterwards, the API calls to Uyuni or SUSE Manager server are triggered. And if we have a look at the event history of one of the managed systems, so you can see here, that's the Uyuni client that you also saw a couple of slides ago. And we see the last task that was executed on this system was the execution of the OpenSCAP XCCDF scan. And previously, the combined patch update was triggered. So first patches have been installed, and after this process succeeded, the OpenSCAP security scan was performed. Going back to the AWX workflow, we can also see here that those tasks succeeded without any issues, and it only took a couple of seconds for all those jobs to complete. So we see, for example, creating the snapshot took 9 seconds, the downtime 8 seconds, and triggering the patch installation and OpenSCAP scans only 8 seconds. That wouldn't be possible manually if you would do this using the web interface. So it doesn't matter whether this is one system or hundreds of systems, it's quite fast, and you cannot beat that with your mouse and your keyboard, I'm afraid. So this demonstrates that this workflow can save you a lot of time if you have a big landscape. And this is the end of the demonstration. So maybe one last slide. Let's talk about the roadmap. So as I mentioned, the first roles have been created 2 years ago, and the Ansible collection, as it's available now on GitHub and Ansible Galaxy, has been initially released in version 0.1 in December 2022. And the current version is 0.1.1 that has been released on April. We added the client role for automating the client bootstrap and registration. Later this year, we plan to release version 1.0. Maybe it's also 1.5 or 1.6. We still don't know. But we want to add an Ansible proxy role in order to automate proxy installations for bigger SUSE Manager setups. We also want to have an automation for the SSL certificate support. So currently, the server role simply installs a self-signed certificate. And it would be great in case you have a certificate authority to have a previously created certificate that will be installed during the installation. Currently, we also still use the XML RPC API because when we started this project or wrote the first roles 2 years ago, there was no new API. So it's quite new, as I mentioned in the beginning of this presentation, but we plan to move to the new API because it's supported with SUSE Manager 4.3 and newer. And for this, we want to create an external Python library that could have the name PyUni. But those are just some ideas we have in mind. But we are heavily interested in what you're thinking. So if you have any ideas or feature requests, let us know, drop a mail, or simply go to the GitHub repository and create an issue. You can also create bug reports. And we are really interested to see what you would like to see in the newer version of this collection. So thanks a lot for your attention. It was totally funny for me to present this. It has been in the works for the last couple of months, and we used it for some customers, and we really like it. And I really hope that you also like it. And of course, have a lot of fun at SUSECon Digital 23. See you next time.